All right, so here we got a summary, basically of all the kind of different rules I've been kind of trying to explain as we went along. And so it's integration by parts, selecting of u and dv. So if we have u dv and we are going to get that, the product of u dv must be equal the original integrand. So we have to actually, whatever, when you multiply it together, it has to be the original integrand, which is the piece here. Also has to be possible to integrate dv. So basically, we're going to use some standard formula or simple substitution to do our integral of dv. So we don't want to choose something we can't integrate, otherwise it's not helping us at all. Now, the new integral v du should not be more complicated than the original one. So if we make something that comes out more complicated over here than what we had over here, that's something we don't want to do. And so the two key pieces, 4 and 5, are kind of what I was talking about as we're going. If we have some x to some power, e to the some ax, let u equal x to that power, and then dv is going to be e to the ax dx. And so that's going to be kind of our standard if we have this form. And if we have this form, when we have the ln, we're going to say, well, u is going to be ln of x to the whatever power, and dv is going to be x to the p dx. And so that's going to be kind of how we're going to choose our examples, and hopefully it works and makes it out so it's easier to integrate. All right, so here we've got integral of x squared to e to the 2x. Now, if we remember, one of the first ones we did was x e to the 2x. So now this time we have x squared e to the 2x. So in this case, we're going to say, well, let's let u equal x squared. Du then is what? 2x dx, if I can write. And so then what does we have? Well, then we have dv is equal to what's left over. Well, that's e to the 2x dx. So we're going to integrate both sides, and we get v is equal to, and now I'm not going to do all the u substitution. I'm going to make, hopefully, well, I'll do it this time, but from now on, remember, u is equal to 2x, du equals to dx. So I have to multiply by 2 here, and so I'm going to put 1/2 out in front. And so that's going to be 1/2 e to the u du, and that's going to be 1/2 e to the 2x. And so that's going to be my v. All right, so now I'm going to take u times v, so I'm going to have x squared times, and maybe I'll put e to the 2x over 2 to make it easier here. And then I'm going to have minus, and I'm going to have the integral. And now I have this part, e to the 2x over 2, and then I'm going to multiply that by the 2x dx. And so it looks like I can cancel some 2s, so maybe I'll do that. That'll work. And so now, what does that give me? And again, I'm just going to work on this integral part here. So that's going to be what? X e to the 2x dx. So here, let's let u equal x, because now, guess what? We have back to here we go, our original thing, x e to the 2x. And so basically, when we get done with this part, we hopefully will get this here when we get done. So that means when we get done, we're probably going to have one extra piece, which we've already found. If we go back, we've already got that first piece here, and then we'll have those 3 pieces at the end. But we're going to just get used to doing the integration by the parts as we go. So here we have d u, not x. Du is equal to 1 dx. And so then we have, I don't know where I want to put this because I'm going to run out of room, I think. Then I'll say, okay, well, dv is equal to what? Well, it's going to be equal to my e to the 2x dx. And I'm going to integrate both sides. And so v is going to be equal to what? Well, it's going to be e to the 2x over 2. Okay. And again, that's because this is what we've done here. So we're doing repeating a lot of stuff, but once you get used to it, you're going to be able to go back and say, oh, I've already done that. I can pull that here and stuff like that. All right, so now this becomes what? Well, this becomes now minus, and we're gonna have u, which is x, times v, which was e to the 2x over 2, minus, and then I guess we can go ahead and bring this down. This is x squared times e to the 2x over 2, and so I'll just kind of arrow that one down. So that's my this. All right, so so yes, we have that, and I'm going to put that in parentheses so I don't forget to do it. And it's because we're subtracting this whole thing. So now we're going and then saying uv, then minus the integral of, now we have the integral of e to the 2x over 2. And then just, then we have the dx. All right. Then here's our dx from that. So that's our du. Can't go all the way back up here because then we'll be in the wrong thing. Now we have in parentheses, and then so then what we can say is, okay, well, now let's maybe move it up here. So now we have x squared e to the 2x all over 2 minus x times e to the 2x over 2, because that's this piece. And then we're going to have plus, and now what we're going to have is we're going to have that 1/2 out in front, and we have e to the 2x dx. All right, well, again, we have that right here. So we're just going to say, well, that's this piece. And so we're saying, okay, well, that's going to be plus, and then we have 1/2 times 1/2 e to the 2x, then plus c. And so our whole thing then becomes x squared e to the 2x over 2 minus x e to the 2x over 2 plus, and now we have 1/4, and then we have e to the 2x and plus c. Okay, so that's the whole thing. So we have 4 pieces for this one, because our first one brought it down, we got something, but then we had to do another integration by parts, and so that one broke down, and then we had to keep going, and so now we have 4 pieces to this one, and so it's getting a little bit more complicated, but as long as we keep going, we know we have the correct answer. Okay. All right, so that's that example. So let's come back for another one.